No one knows about this motor, but they should. Because deep inside the quiet corridors of the electric vehicle world, something remarkable is happening. It's a story about power, secrecy, and technology that could blur the line between transportation and defense. And it begins, as many stories do, with Tesla. For years, Tesla has been the company that others chase. They built the first truly desirable electric car. They made battery packs a symbol of modern engineering. And every time the industry seemed to catch up, Tesla moved the finish line again. But now, attention is turning toward a project that almost no one talks about: a next-generation electric motor. And, according to a few quiet indicators, possibly far more capable than anyone expected in ways that might scare some people. Tesla's public presentations have hinted at it. At Investor Day, engineers briefly mentioned an unprecedented motor architecture that would remove rare earth materials altogether. A noble environmental goal, but also a strategic one. By eliminating rare earth magnets, Tesla could make its supply chain less dependent on China, where most rare earth mining occurs. That alone is $1 billion advantage. But there's another layer to that story. Because the same motor designs that reduce dependence on magnets also enable something else: greater torque, higher temperature tolerance, and resilience under extreme loads, qualities that happen to be highly valued in military hardware. According to patent databases, Tesla has quietly filed dozens of updates in its motor portfolio over the past 3 years. One of them, titled Geometry of Rotor, End Ring, and Stator End Turns, describes reshaping internal components to cut electrical losses and boost output density. In simple terms, it's about squeezing more power out of less metal. That's the kind of efficiency that can make the difference between an ordinary EV and an energy platform suited for heavy-duty use. On its own, that's impressive, but when combined with what's happening elsewhere in the industry, it becomes more intriguing. Because Tesla isn't the only company experimenting with military-grade electrification. In 2025, CRG Defense, a US engineering contractor, announced a $2 million Army contract to develop high-voltage electric motor generator systems for hybrid tactical vehicles. General Motors has its own defense division, adapting commercial battery packs for the US military's next generation of trucks. And across the Department of Defense, new projects are exploring how EV propulsion can be applied to drones, field generators, even armored transports. It's part of a quiet but deliberate push toward electrified mobility in national defense. What used to be a consumer experiment has now become a matter of strategy. So where does Tesla fit into all this? Officially, they don't. Tesla has no declared military contracts, no public partnerships with defense agencies. But their technology, open-sourced patents, specialized suppliers, and the global race for electric dominance moves in circles that increasingly overlap with military research. Suppliers that build drive units for Tesla can also bid on government projects. Component makers that design high-density inverters for EVs can adapt the same designs for armored vehicles. And in a world where information travels faster than ever, lines between civilian and defense engineering blur almost naturally. Take the example of the magnet-free motor. Traditional permanent magnet motors rely on neodymium, an expensive and strategically sensitive material. China controls nearly 90% of its global supply. By removing it, Tesla isn't just making a cheaper motor, they're removing a geopolitical choke point. That alone would catch the interest of anyone thinking about supply chain security, whether in Silicon Valley or the Pentagon. Independence from rare earths means independence from influence. And in today's world, that's a form of power. In the background of this technological race, whispers of a mysterious supplier have surfaced: a manufacturer developing advanced motor casings using aerospace-grade alloys. Nothing officially connects it to defense work, but the materials themselves, titanium composites, carbon fiber rotor housings, sound like something built for environments far harsher than city streets. Industry analysts have pointed out that some of Tesla's procurement filings refer to high-stress rotor assembly tests performed at off-site facilities that remain unnamed in public records. Those details could mean nothing, or they could mean everything. In innovation, context is often the story. Meanwhile, the Defense Department's own research roadmaps openly mention adapting commercial EV tech for military use. The reasoning is simple. An electric motor is quiet, efficient, and reliable. For reconnaissance vehicles or field generators, silence is a tactical advantage. For logistics, eliminating fuel convoys reduces risk. The same qualities that make an EV appealing to a commuter make it invaluable to a commander. So when you see breakthroughs in torque, cooling systems, or energy density, the military world takes notice, whether the companies involved realize it or not. Inside Tesla, many of these developments are no secret. Engineers regularly publish white papers on rotor dynamics, silicon carbide inverters, and heat-resistant insulation. But those documents are dense, technical, and easily overlooked. To most viewers, they're just another engineering milestone. Yet when you line them up with defense industry trends, a pattern starts to emerge: parallel evolution between consumer and tactical technologies. Two different worlds chasing the same efficiency frontier. It raises a question that no one seems to ask out loud. Is Tesla's innovation merely inspiring defense research? Or are both industries quietly converging on the same goals? The answer might lie not in Tesla's boardroom, but in the network of suppliers that orbit around it. Companies that make advanced stators, carbon composites, or heat exchangers rarely operate for one client only. Their expertise flows wherever there's funding, and lately, that funding increasingly comes from governments investing in electric propulsion. So while Tesla remains publicly civilian, the technologies around it are already dual use by nature. Some experts call this the gray transfer, when civilian technology migrates into defense without formal contracts or intent. It happens through patents, shared talent, or open research. And Tesla, by releasing many of its patents under open licenses, has unintentionally made that process easier. Anyone, including defense contractors, can study and adapt those designs. That doesn't mean Tesla is secretly building weapons. It means their work is so advanced that others are eager to adapt it. It's a compliment, but one with consequences. In August 2025, when CRG Defense announced its Army contract, it emphasized one goal: creating electric drive units that could withstand sustained operation under extreme loads. If you replace the word tank with semi-truck, that statement could describe the Cybertruck's design philosophy almost perfectly. The crossover is uncanny. Civilian ambition meets military resilience, both chasing the same mechanical truth. The future belongs to silent power. Yet amid all this progress, there's silence from Tesla itself. No press release, no hint of partnership, no public comment on defense applications. Maybe that's intentional. Tesla has built its image around sustainability, not warfare. Acknowledging even a symbolic overlap with military tech could complicate that brand. Or maybe the truth is simpler. The company is focused solely on efficiency, and the world around it is the one drawing connections. After all, innovation often moves faster than the stories we tell about it. Still, the speculation persists because the logic is too strong to ignore. When a company pioneers technology that redefines power, density, and heat resistance, others will adapt it. When a supplier perfects a rotor strong enough to survive enormous stress, someone will test it beyond its intended limits. And when global powers compete for energy independence, every motor, every battery, every idea becomes a strategic asset. In the end, it may not matter whether Tesla intends any of this. What matters is the ripple effect. By chasing the perfect electric motor, Tesla and its partners are creating tools that can serve both commuters and command posts. The line between civilian and military innovation has never been thinner, and in that thin line lies both opportunity and danger. No one knows about this motor, but they should. Because the real story isn't just about a car company, it's about how technology born in garages and gigafactories can reshape entire industries, economies, and perhaps even battlefields. It's a reminder that in a connected world, every breakthrough echoes far beyond its origin, and that sometimes progress moves so quietly, we don't notice the ground shifting beneath us until it's already changed. If this is true, the EV world will never be the same.